In problem number 1 of our practice test 1, we are asked to generate or find the first 5 terms using the explicit formula. So we're given a formula. So let's find our first term, y sub 1, would be negative 5 times 1 minus 5. So it would be negative 5 minus 5, or negative 10. Y sub 2, same thing, only for the n, we're going to substitute in 2. So this would be negative 10 minus 5 would be negative 15. Y sub 3 would be negative 5 times 3 minus 5. And that's negative 20. Well, I see a pattern going on here, negative 10, negative 15, negative 20. So I'm going to say my next numbers are negative 25 and negative 30. We've got a little arithmetic sequence going on here. What I'd like you to do now is press pause and work problem 2 on the worksheet. It's almost identical. Number 3, what is the 15th term, that's n, in the sequence using the given formula? So our notation, C sub 15, is 3 times 15 minus 1. That'd be 45 minus 1 is 44. When we talk about showing our work, I need to see all of this. An answer of 44 will not earn us any credit. Again, press pause and work number 4. Question 5, write a recursive formula for the sequence 7, 13, 19, 25, 31. Then find the next term. Well, remember, a recursive formula has 2 parts. It's got the first term, and then it says, what do we do to the term before it? Are we going to add something over here, or what are we going to do? So let's take a look here. What's happening? I think that's adding 6 to each of these. Okay. So what we want to do is say that our first term is 7. And what do? We take the term before. Remember, this means the term before. And we add 6 to it. So there's our recursive formula. And then it wants us to find the next term. Well, 31 plus 6 would be 37 for our next term. Again, press pause while you work number 6. Number 7. Suppose you drop a tennis ball from a height of 8 feet. 8 feet. After the ball hits the floor, it rebounds to 80% of its previous height. How high will the ball rebound after its 3rd bounce? Well, if we look at what's going on in our pattern, the ball starts at 8 feet, and then it travels down and bounces back up. So our first bounce here, we're going to call this our first bounce. It's not really going to be 8, our starting. And again, we would bounce a little bit less each time. So when I'm looking at my series of numbers, I really want to treat this like the first number, and the second number, and the third number, and the fourth number. So what I'm going to say is that our first term is 8, even though it's not our first bounce, it's the first number in our pattern. Our common ratio is 0.8, and the number of terms we're going to look at is 4. So we are in geometric. When I look at my blue chart for geometric, and then underneath there I find the explicit formula. I find that my formula, a sub n, equals a1 times r to the n minus 1. All we need to do is substitute in our numbers. So a sub 4 is going to be our first number 8 times our common ratio 0.8, and then it says it's to the n minus 1 power, so that would be to the 3rd power. When we do that, I get about 4.1 feet. The problem asked us to round to the nearest tenth, and so that's why we have 4.1. Let's move right along then. I'm assuming you've done number 8. Number 9, the table shows the predicted growth for a particular bacteria after various numbers of hours. Write an explicit formula for the sequence of these numbers. Well, if we look at this, a couple different things happen. We could say that this is 21 times 2. It's also 21 plus 21. But if we look at the difference here, we're not multiplying by 2. We're adding 21 again, and all of these are adding 21. So this becomes arithmetic. And what we know here is that our first term is 21. Our common difference also happens to be 21. Just kind of a strange coincidence. They ask for the explicit formula. Well, under arithmetic, if we go to explicit on our blue sheets, we find the explicit formula a sub n equals a1 plus n minus 1 d. We don't have something to substitute in for n because we're looking for our general formula. So a sub n is going to be 21 plus n minus 1 times 21. And if I distribute there, we get 21 plus 21n minus 21. Let's see, these are going to cancel out, so we're just left with 21n. So our explicit formula, a sub n, is going to equal 21 times n. Again, pause while you do number 10. Number 11. Is the sequence arithmetic? If so, identify the common difference. Arithmetic is where we're looking if we're adding the same number. Let's see, that's a plus 7 and a plus 7 plus 7, so this is a yes. And our common difference is 7. Pause really quick and try number 12. Number 13, find the 110th term of this sequence. Well, I guess that's our n, 110. Here's a1. We don't know if it's geometric or arithmetic yet. Let's look here. That doesn't look like it's multiplying. I think they're adding 10 there. Negative 7 plus 10 is 3. And 3 plus 10 all the way through. So we have an arithmetic sequence. Our common difference is 10. We're asked for one specific term, so we need our explicit formula. And they asked for the 110th term, so a sub 110 equals a1 plus 110 minus 1 is 109 times 10. And when we work that out, we get 1,083. Pause while you try number 14. Number 15, find the missing term of the arithmetic sequence. That means we want the arithmetic mean, or in English, it means we want the average. We're just going to add those up and divide by 2. Try number 16 real quick. Number 17. Viola makes gift baskets for Valentine's Day. She has 13 baskets left over from last year, and she plans to make 12 more each day. If there are 15 work days until the day she begins to sell baskets, how many baskets will she have to sell? Let's see. On day 1, she had 13 baskets from last year. And plus she's going to make 12 more. So she's going to have 25 baskets on that first day that she can sell. And then on day 2, she starts the morning with 25 baskets and adds another 12 to it. So she has 37. So if we look at what's happening here, taking our 37 plus 12, we're really increasing here by 12 baskets every time. So that's going to be our D. Our A1 is actually 25. It's not 13 because at the end of the first day she has 25 baskets. And she wants to proceed with this for a total of 15 days. So we have an arithmetic. We need our explicit formula because we have one term. So I'm just going to write it again. So on the 15th day, she'll have A1 plus n minus 1, 15 minus 1, times 12, and that comes out to 193. Pause, take some time right now to work on number 18. This is one of the trickier questions. It's on the test, so take some time. Get number 18 figured out. Number 19, is the sequence geometric? If so, find the common ratio. Well, when I look at these, 6 times 2 gives me 12, and times 2 times 2. So this is a yes, because we're multiplying by the common ratio, 2. Try number 20 real quick. 21 wants to know what's the 5th term of the geometric sequence. I could do formulas, but boy, look at this. We're just missing 2 numbers. And our common ratio here would be to multiply by 3 each time. 45 times 3 is 135, and 135 times 3 is 405. So I just kept multiplying by 3 each time. That's n times 3. Give number 22 a quick try. Number 23, write an explicit formula for the geometric sequence, then find the 5th term. Well, explicit for geometric is a sub n equals a sub 1 times r to the n minus 1 power. So let's make sure we have everything. Here is our A1, that's given. Our R, from -4 to 8 and then to -16, looks like we're multiplying by -2 there. So let's write our explicit formula. A sub n is going to be our first term times -2 to the n minus 1. That is our explicit formula. And then it wanted the 5th term. So a sub 5 is going to be -4 times -2 to the n minus 1. 5 minus 1 is 4. When we work that out, it comes out to -64. Please press pause and work number 24. The video continues with problem 25 in part 2.